Hi, everyone, and welcome to the Cloud Infrastructure in 2022 Summit. Today's event was organized by the hardworking folks at Redmond Magazine and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, VMware, one of the world's leading providers of virtualization and cloud computing solutions and services, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of three information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsors have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. At the end of the summit, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors do read every comment, and they help to shape our future events. And last but not least, at the end of the third session, one lucky attendee will be receiving a Surface Pro 7, Microsoft's ultralight tablet featuring a laptop-class Intel Core processor, all-day battery life, and HD cameras. But you must be present to win, so stick with us. Now let's get started with our first session, Top 10 Tips for Cloud Infrastructure Heading into 2022. For this session, we've called on two experts in the field, Dave Kawula, Managing Principal Consultant at Tricon Elite Consulting, and John O'Neill Sr., Chief Technologist at AWS Solutions. Dave is a Microsoft MVP with more than 20 years of experience in the IT industry. His background includes data communications networks within multi-server environments, and he has led architecture teams for virtualization, System Center, Exchange, Active Directory, and Internet gateways. John has also worked in IT for more than 2 decades. His roles have ranged from software architect to senior executive, consultant to author. He's been involved in multinational networking, messaging, and communications projects. He's developed technology training courseware for Pluralsight and authored material for both Thomas Reuters' Aspetor books and Exec Blueprints. Both of our presenters are sought-after speakers, and I know you're in for an absolutely great session. Take it away, Dave and John.
Awesome. Thank you very much for having us, John and team. Of course, I'd like to take a chance to have a shout out to our sponsor, VMware. Thank you very much for making this event possible. And John, as we get started with this, there's one very important topic that I'd like to talk about. It's the fact that in my introduction, I have 20 years of experience and you have 2 decades, and your 2 decades actually sounds like a lot longer than my 20 years. So.
Well, I'm older than you, so there you go.
Well, so this session, John, that we're called on to do is the top 10 tips for cloud infrastructure heading into 2022. And you know what? Out of all of these sessions that we've done, I think this is actually one of the most difficult ones to come up with content because, cloud is just so big for so many organizations right now that narrowing this down to a band of top 10 was very difficult. So there's probably a lot more that we could talk about beyond this. This could probably be the top 100 tips, but we've really narrowed it down. And, all day, every day, we're in the cloud. We both started as on-prem administrators and have made the journey into hybrid and cloud infrastructure. And, I'm really excited to get this going. How about yourself, John?
Absolutely. I totally agree with you. This was a challenge because not only picking those top 10, but, the cloud is so broad for so many different folks and organizations that picking the ones that are going to have the most common impact was pretty tough.
Absolutely. Well, let's get started. So our first tip, all of the different identities that we have out there now, John. We have cloud identities. We've got our on-prem identities, typically powered by Active Directory. We've got hybrid identities. And the big concern that I find that most organizations have now is how to secure this, because you have so many different entry points into your infrastructure now, so many different ways to manage and configure the things that we used to have with just kind of that single identity. And, having a unified identity is part of that as well. Like, what are your thoughts for our viewers today just surrounding identity protection and how important protecting access into our infrastructure is?
Well, Dave, we've talked about this at length. I truly feel that identity is the foundation upon which cybersecurity is built. So not just understanding it, but managing it and properly controlling it. Because at the end of the day, when we do our postmortems on malware attacks, ransomware attacks, that kind of thing, in almost every case, there's some sort of compromised credential, right? And it doesn't have to just be a user level account. Computer accounts are identities also in Active Directory. So when we talk about identity management, we're not just talking about the first things that come to mind. We're talking about all those different identities that exist in the world of your organization's directory. And some of the things that, we talk to a lot of people about are, first, the concept of you have to choose what your primary identity management system is going to be. And everybody goes, oh, that's for us, that's Active Directory. And then you look, and they're using things like SQL native authentication on their SQL servers, right? And they have, XYZ legacy app that they've just created user accounts with passwords in and everything else. Well, if you're doing that, you do not have a single root source of identity, because now each of those is being relied on to provide the same protection as your Active Directory system. And what do you want to bet that legacy app didn't have as much skill or time or resources put into protecting its identity? And also, what do you want to bet that your users aren't using the same password or setting the same password for that legacy app or that SQL native authentication user that they use for their Active Directory domain? We train users, but they still do it. So if you're going to have all these different identity management systems, you might as well just accept the fact now that your identity management strength is only as strong as the weakest of those systems.
So, and I think one of the biggest pieces along that point, John, is the fact of where do your credentials get left behind as you're hopping around through the infrastructure. I remember we were doing the security audit from a few weeks ago for an organization, and we noticed that one of the admin accounts had logged in the last month, over 100,000 times? Well, that's not even possible. But then you have to think, okay, well, what is wrong? What's misconfigured with that administrative account? Has that administrative account been used to install some application? Is it running a certain type of a service or something like that, and it's authenticating that many times? So we need the ability to go scout that out. And I think when you look at your identity protection solution, you have to look at all of the scenarios and what's encompassed with them. So, you want to protect the cloud portion, the on-prem and the hybrid portion, because even if it's the same account, you're using them for vastly different things. So, looking at identity protection for me, it's just so important moving into 2022.
And Dave, if you don't mind, if I can just daisy chain on that, because you made me flash back to a few other things that you and I have been called in on this year and faced, and things like domain admins being used to log in to servers or even workstations. And you and I, how much time do we spend reminding IT pros that a domain admin account is only needed for one thing, and that's to log into a domain controller. It isn't needed to log into any of your other servers, any of your other workstations, and even on that domain controller, it's only required for certain things. If you're running DNS on your domain controllers, lots of people do, because of course Active Directory needs and lives and breathes off of DNS, but you don't need a domain admin level account to restart the DNS service, right? You can use GM points and that kind of thing. So just the conversations we're having with fellow IT pros about, stop using domain admin level accounts. We get that it's convenient, but those cached credentials can be used so easily by attackers for lateral movement that it's just not worth it. And then the other is, if you can't get that group managed service account working, or, a vendor tells you, oh, we don't support, this kind of thing, don't take the easy way out and use your admin account to run that scheduled task or run that service, because you'll eventually forget that it's there, and then it becomes a point of compromise. So those are just two kind of thoughts that I had after you were bringing that up. And I don't know if those thoughts were nightmares or just general thoughts, but I wanted to get them out there.
Oh, one more big tip for everyone. If you check off that checkbox, password never expires, stop doing that right now. I don't care if it's for service accounts, for anything. Those passwords need to change. They need to rotate. So please stop doing that. That would be very helpful.
Right, Dave? I mean, I told somebody this just recently, and I can't even remember the context of the conversation other than, it came down to that discussion. Well, I can't be managing this. And I'm like, do you understand that the whole purpose of managed service accounts and group managed service accounts, the whole premise of it was to have an account that could run a service and still change the password according to best practices and policies. So when you choose to do something different and just never expire the password, you're really just putting yourself in place where someday you may be called to answer to your organization for why you took an action that left the company, with its pants down, so to speak.
Absolutely. Okay, on to topic number 2. We have been running traditional storage for the better part of 30 plus, maybe even longer than that. And that traditional storage sees us having NAS devices, CIF shares, SANs that are out there. We could have hyper-converged infrastructure. And please, before you go through some type of a migration project, can we get file server cleanup projects scheduled for 2022? Because this one always goes into the back burner. And John, I want to introduce a brand new concept to everyone here today, and it's called the cascade effect. It's something that I've actually come up with myself in IT. And what the cascade effect is if I have, for example, and I'll just pick a round number, 100 gigs of storage. Well, part of our DR and recovery plan is that, I want to have 2 copies of that backed up, so there's 200 gigs right there. I want to replicate that to the cloud. That's 300 gigs right there. What I find with the cascade effect in regards to DR and recovery is it could have a 3 to 5x multiplier on what you're seeing in frontline storage. So when someone comes up to me from the IT team and says, hey, I just want to go add 100 gigs to the server, in my mind, I'm thinking cascade effect all the way through, John, and saying, listen, that 100 gigs actually equates to 300 to 500 gigs of infrastructure behind the scenes to protect it. Do we really need it? And then I get to thinking, well, maybe we just need to hit the delete button on some of this data that's not required anymore. Has anyone analyzed that? Because there is a cost to every gig that we have on the network. What are your thoughts on this, John?
Dave, do you remember that recovery we were called in on, and it literally took days to recover their file servers because we were limited by the technology they had in place, and they had these multiple terabytes. I mean, it was many terabytes. And so it took all this time, and in the meantime, the company's down, they can't access their engineering drawings and that kind of thing. And we did a postmortem after everything was back up and running, and we looked at it, and over 85% of the data that we restored, 85% of the data that caused all these users to be offline for all that time hadn't been touched in over 8 months. Most of it hadn't been touched in over a year. So imagine the value to the organization if that data had been proactively archived, to blob storage or to, some sort of cold storage type environment where, yes, you could still get it if you needed a file for a customer complaint that was 4 years ago or whatever. You can still get it. It's just not on that live storage. If that had been done, we probably would have had that system back up and running and those users using their data within a few hours, not a few days. And the only difference required wasn't a technological difference, right? It wasn't, I need to buy extra software licenses or whatever. It was literally just taking the time to manage our data because, let's face it, in IT, it is more common than not that we walk in and we see that scenario of, an episode of Hoarders. We could literally make a show, IT Hoarders, because the more storage you give them, the more they stuff in there. I keep thinking of sometimes you're out and you see a barn and then you see like a sub shed that's built on the barn and then a back to that and everything else. And I could just imagine to myself that, yeah, okay, they built the building, they thought it would be bigger than they ever needed, and they just kept saving everything. And then they needed more storage, so they kept saving everything, and they kept saving everything. Well, when they want it or when they need to recover it, it takes a lot longer. So this concept of the cascade effect that you brought up and the concept of being able to meet things like RPO and RTO, particularly with hybrid cloud environments and that sort of thing, requires IT pros to really take a proactive management role with their users to manage the data. And I get users are all about convenience, so they're like, hey, I haven't accessed that file in 3 years, but when I need it, I need it. Okay, this is where a conversation comes in. We understand you need it and you're going to have access to it, but instead of being accessed within 30 seconds, it'll be accessed within 24 hours or something like that. And most companies, most organizations can survive.
Well, and the technologies are out there, and I think that we've classically trained our users with technologies like Microsoft OneDrive for Business, where with that, we can actually take and have the ability of just right-clicking on files and saying free up space on our local machine. We don't have to keep those sync copies. So the concept of tiering is actually built right into the client and user experience now. I don't think that it's something that's going to be really hard to work with our users on from a tiering perspective. Yeah, it might take a couple extra seconds to retrieve that file, but tiering up those what we'll call cool files and only keeping the ones that are hot and frequently accessed. Honestly, most file servers that I see, you're probably only 10% of the files or less that need to be inside of a hot tier. The rest can just go off into dark storage to be fetched at some later point in time. The other challenge that I have with this, John, is the fact that, we've worked a lot with hyper-converged infrastructure recently in the last 3 to 4 years, and we've moved away for a lot of organizations from traditional spinning disks to fast NVMe-based SSD or faster storage. Well, there's a big price point to just having gobs of data just living on the network, right? And so, so please hit the delete button because it's probably time to do that. And by the way, that barn and the additional shed, you're basically describing my house. Thank you very much.
I wasn't going to tell anybody that, but since you admitted it, I'm okay with that.
All right, the not-so-fun topic of cloud. Number one, by default, all of the security measures are not enabled inside of your cloud tenants. This is not something that is going to be fully protected. It's going to have a certain level of protection, but it's not going to be in what I'll call like a full guard where you're going to be fully protecting. We need to have advanced persistent threat protection. We've talked about this many times in previous sessions, Sean, but it's so important that you have this on your servers, you have this on your desktops, because this is your protection against the bad guys that are out there. And I like to just think about it this way. When you work with your infrastructure or you build, let's say, a Windows 10 desktop for your company, do you just pop in the ISO and do you make a bootable USB stick, install Windows 10, next, finish, join it to the domain, and forget about it? Because I can honestly say that there's probably some hands that are out there right now. They're saying, well, yeah, that's what we did. Well, that's not good enough anymore. You're leaving so much low-hanging fruit for the bad guys right now. that we need to protect these things. So one of the things that I love about advanced persistent threat protection, especially a lot of the products that are out there today, John, is the fact that they do inline vulnerability assessment, and they'll actually tell us if we're having poor administrative practices, because we only know what we know in IT, and maybe we weren't taught any different for how to build things. And so this will actually help us proactively lock down those environments. And remember, just because something's built in the cloud or you have some type of a hybrid connection, it doesn't mean it's secure. You as administrators still have to go and lock it down. Thoughts, John?
So there's a few here. The first one is, and Dave, this is actually quoting you from a talk we did a while back, and that is that the cloud doesn't automatically protect you from ransomware, right? There's this misconception by some people that think, okay, well, I've connected to the cloud, so now I'm protected against ransomware. No, it absolutely, just being in the cloud does nothing to improve your ransomware stance. It protects you against things like, floods or the loss of a single data center, but it doesn't do anything with ransomware. So you have to turn those protections on. And, when I talk about cybersecurity in general with folks, one of the things I like to bring up is the concept of the OODA loop, or observe, orient, decide, and act. And it was a strategy developed by the military, but it's been put in use in business and legal areas and everything, because it really simply tells us that the organization or the individual that can do that the fastest beats their opponent, right? And so this was all designed around air-to-air combat and dogfighting and everything else. But it makes a whole lot of sense, because if we observe, orient, and decide faster than our opponent, than that threat actor, right, then we change the things that they have to observe and orient to. So whatever decision they were about to make may not apply anymore, because the decision we took changed it. So if we're getting in front of these threats and we're really implementing advanced persistent threat protection and identity management, the things we've already talked about, if we're doing that properly for an entire organization, for our cloud resources, for on-prem resources, then we can change the scenario so much so that the attacker's likelihood of success against us is lower. And the final thing that I was going to throw out there on this is that absolutely, if everyone looks at the cost of remediating malware, and if you don't think malware hits close to home, I encourage you to investigate in your community, in your county, in your state, your province, wherever it is. Just do a little bit of research and look at how many people, how many organizations this year have been affected in that little area by ransomware and malware. I think you'll be shocked. And what you'll find is the cost to deal with it after it occurs is way less than the licensing cost you'll pay for things like Microsoft 365 E5 licenses compared to just the Office 365 variants and that sort of thing. So invest up front so that you don't have to pay the heavy toll on the back end.
Awesome. All right. So this actually leads very nicely into our next topic, John. The cloud does not protect you from ransomware. And that's a very bold statement, because, cloud technically can protect you from ransomware. But just because you've spun up something in your favorite cloud provider of choice, like I said, it does not mean that it's secured by default. And we actually have a question that came in that's directly surrounding this, and I'm just going to go click on this one here. So we've got a great question that came in from Michael. I'd like to thank you for the question. It's, can you name some obstacles when implementing cloud infrastructure into a large hospital system? And Michael, that question is so relevant because it's directly related to this particular slide. And so you can think of that same scenario of having the next finish Windows install. For all intents and purposes, you're going to take and you're going to have a similar experience in your cloud tenant. It's up to you to choose how much you want to secure that. And so I'm a Microsoft person through and through, so I know a lot about Azure and on-prem Microsoft infrastructure. And in Microsoft Azure, they have a solution to this, which is called an Azure Blueprint. And an Azure Blueprint is a preset of prescriptive policies that lock you down to get you compliant out of the gate. So if you're moving to cloud infrastructure as a large healthcare provider and you haven't spun up that tenant yet, why not start in a fully HIPAA-compliant, 100% auditable tenant out of the gate? So instead of you having to come in behind and secure things after they're built, you can start that way. So my biggest piece of advice for you, Michael, is that you start looking at things like Azure Blueprints right away. The other cloud providers that are out there have similar technology, so if you use them, no problem. But that's a big one. So John, what are your other thoughts on this one here?
Well, I kind of gave away some of it going on the earlier slide, but I'm just going to really daisy chain on what you said. Take advantage of what those folks and those organizations who get to invest and spend, 40 hours a week, every week, devoted to just figuring out how to lock down, not even your entire tenant, but just even specific parts of it, right? And so let's talk about, SQL Azure or that kind of thing. There are groups that get to spend this time to come up with these blueprints and these security settings that they, researched and tested and did all these things. Now, you still have to do some testing. You have to still do some due diligence to make sure that they fit in your instance. But instead of trying to wing it and figure it out on our own, where we have to spend 40 hours a week doing 40,000 different things, why not take advantage of those things that are available to us from dedicated resources? I mean, the same concept is one that I put out there of why we have such a difficult time defending against some of the current threats, right? You look at some of the current malware and it's nation state sponsored. So not only is it these organizations that are spending, 40 hours a week, and I just use that number to indicate all their time in a work week, they spend that trying to attack you. Well, now they're funded by country-sized economies, and we have to hold them back while still making sure that our company's ERP system, that our company's health records system, right, or our EMR, if we work in a hospital system or a physician's office, we have to make sure all those things work in addition to the security role. So one great piece of advice that I've found, a pro tip if you want it, is like Dave, you were talking about, make sure you're taking advantage of that work that has already been done, and you can just put it in play. And at the end of the day, you're the one that's going to look like the hero to your organization, because they don't care where you found it or whatever or how you came by it. What they care about is you kept the wolves outside the house, so to speak.
Yeah, absolutely. And I often get questions, John, on hardening your Windows server environment. And this could relate to both on-prem, hybrid, or cloud. And what are the best ways to, harden those configurations? Well, if they're Azure-based resources, through products like Azure Defender, you can take and you can have hardening kind of built in. But what if you have on-prem infrastructure? And, where are you going to find those template group policies and things like that? Well, if you want to get it from Microsoft, you can use Security Compliance Toolkit. They've got sample GPOs in there as well. And I'm also a big fan of the community with the Center for Internet Security, because in there, they've got all that prescriptive guidance for locking down and hardening all your infrastructure. Another interesting one was MFA policies and what your organizational MFA policies are today. If you do not have MFA roadmap, and that's multi-factor authentication right now, today, you need to get it there, because what you might unknowingly be doing is falling out of compliance with your cyber insurance policy, because many cyber insurance policies today, the renewals and the new attestations are requiring that you have MFA. And so, John, do you want to just quickly talk about that, and then we'll move on to the next topic?
Yeah, absolutely, because you know how much of my time this is taking lately with cybersecurity insurance, and the gist of it is that cybersecurity insurance now, because of the level of impact, it's very similar to when you think about flood insurance or hurricane insurance, these catastrophe level insurance events. Those aren't absorbed by single carriers. So when you buy a hurricane policy or a flood policy, it's underwritten by groups of insurance companies that come together so that they can cover it. Because otherwise, there's no single insurance company that could cover the damage, for instance, that was done by Hurricane Katrina. And in addition to the fact that they pool and they group underneath, it is also backstopped by the government to a certain point. None of that exists right now with cybersecurity, except for the fact that the level of the impact of some of these events, one that Dave, you can speak a lot. We were involved big time with a number of affected entities of the Kaseya breach. If you look at the total cost of that event across insurance carriers, you can see how that could cripple or even bankrupt individual providers. So, in addition to the fact that, probably there'll be some government level backstops that'll come eventually, but what's coming right now is that these insurance carriers are tightening their requirements for what you're doing. And when you attest to them that you're doing it, when the event happens and you make a claim, if they come back, and they will, more and more often now they will come back and verify that the attestations you made match what was in place when the event occurred. And if they don't exactly match, they will deny your claim. So if you have cybersecurity insurance and you have a $10 million event, you've got $1 million deductible, right? You've paid the other $9 million, and now you're just trying to get reimbursed from the insurance company because, Dave, as you know, that's how it works. They don't pay up front. They reimburse you. Well, before they reimburse you, they come in and they say, okay, well, one of the requirements that we had that you filled out on our questionnaire was that you had multi-factor authentication in place for all remote users. So any user that uses a VPN, any user that connects up to the cloud tenant, whatever. And you attested that, yes, we use MFA. Well, they come in and they look, and they see that you only have MFA enabled for your admin users. Your claim just got denied. And it doesn't matter if the lack of MFA was part of the breach mechanism. What matters is that you filled out a questionnaire and your answers didn't match the reality, and that gives them a basis to deny the claim. So, the advice, and the reason I spend so much time talking about this right now is because the last thing I want is for any organization and any IT pro of any organization to be in a position of needing that insurance that they expect to be there and having it not be present because of something they didn't understand or they didn't do, right? It's bad enough to just choose not to have the insurance, but it's even worse to have it, to think and feel that it's going to protect you, and then to find out that, oops, I made a mistake and I didn't do this. And I know a lot of organizations out there, and I'm not calling fault on anybody, I'm just saying this is the reality. A lot of organizations out there, when they get these questionnaires, they just fill them out as fast as they can to move on with their day. And you really don't want to be doing that right now.
Awesome. All right. Cloud Tips 101. If you're new to cloud computing, especially in Azure, there is a little button when you configure, and I'll just use the example of an infrastructure as a service virtual machine. This would be what you'd know as an Azure VM. There is a button in there for a reserved instance. And what many, many organizations don't know today is that you can turn your OpEx expenditures in the cloud into CapEx expenditures by prepaying for 3+ years. This drops your cost of that virtual infrastructure in the cloud down significantly by using reserved instances, especially if you're going to be looking at going through some type of a migration project where you're going to be moving a portion or all of your infrastructure up to the cloud in 2022. This is one that could be a real game changer for you, because I'm not going to speak to the actual percentages that you save, but if I said hypothetically that you could save 30% a year, by doing this, that's significant. So if an organization is spending $10,000 a month, you've got $3,000 back in your pocket per month, $36,000 back in your pocket for a year. Well, that goes a long way towards doing other things. Maybe that buys you your new hyper-converged infrastructure setup that you're looking to get. Maybe that helps you true up on some of your licenses. The next thing is not even just with the prepay and save portion of this, is make sure that when you look at moving infrastructure to the cloud, or if you already have infrastructure in the cloud, you have to ask yourself one very important question. Because when you run infrastructure on-prem, there's no real cost for you to run that infrastructure by the minute. However, when you run that infrastructure in the cloud, there is a cost per minute or hour. That's how they price it. So it's, hey, per hour of runtime on this, you're going to pay X number of cents to run this particular service. Wow. So if I've got that developer system that's only needed Monday through Friday, 9 to 5, nobody ever logs into that stuff beyond after work hours, overtime, they're just not in there, consider shutting that down. Because that could introduce, if they're operating on an 8-hour workday, that could potentially introduce as much as a 66% runtime cost savings on that virtual infrastructure. You really need to wrap your head around how it is that you're going to be taking and managing that cloud infrastructure, and it is completely different than managing that on-prem. So 2 things for me is the reserved instances offer huge savings and planning on those shutdowns. John, anything to add on this one?
No, you really covered it. For some organizations, I will take a little bit of a different perspective that goes on it. That this is a great opportunity for an organization to better tune the way they pay for their cloud infrastructure, right? So instead of being flat and just having to do what's out there, you can now choose the model that works best for you. Some models work better where we can turn it into a capital investment. There's some debate on this because, hey, it's not actually a tangible thing, so is it really capital? But remember, you're buying the same tangible thing you would in a box. So you're buying compute, you're buying storage, that kind of thing. So, just like Dave said, you can turn that into a capital investment. But if your organization is better suited to an environment where, operational costs month to month that can vary based on month to month demand, say that you have a very seasonal business where you're into the downhill ski industry or something along those lines, where you need to use a lot more during certain months of the year and then not much in the others, and year over year you don't really know what your growth or your need is going to be. So maybe that operational mode works better for you. The concept of reserved instances and everything Dave just talked about gives you the flexibility to align how you're paying for your cloud resources to what your organization needs and can best benefit from. You're no longer forced into just that simple, straightforward pay-as-you-go model.
Perfect. All right. Privileged identity management. Oh boy, if you haven't looked at this one yet, 2022, turn this on inside of your tenant. It's actually available kind of by default inside of your Azure tenant if you weren't already aware. Features of Azure Active Directory and other cloud identity providers that are out there. And the big thing that we have to get away from here is thinking of the concept of the global administrator doing everything inside of your tenant. I want to have 2 things, John. I want to have role-based administrative access where I'm only giving the rights that are required, so the principle of least privilege. And number 2 is I only want to be giving those access rights for a limited amount of time, and I want to be able to go through some type of a approval workflow. Now, where this is built in and where I've used this quite extensively is with Microsoft Endpoint Manager, what you guys would know as Intune. This is actually built right in through Azure Active Directory and the connectivity inside of there. So if I need to go through some of those roles, I can request access, I can up-level request my access, and I can give myself that just-in-time access that I require. And this plugs so many holes for me from a cybersecurity administrator, because one of the biggest problems that I know is that, that over-elevated account that we forgot that we had logged in somewhere, and it becomes very problematic. And this just solves all kinds of problems for us. So for me, 2022, privileged identity management definitely needs to be on the hit list. John.
Yeah, so a couple things here. First, for anybody who isn't thinking least privilege and zero trust, first, anytime any permissions issue comes up, you need to start repeating that as your daily mantra, right? Anytime anybody asks for anything, and I don't care whether it's within an application, I don't care if it's, that admin role or the domain admin role, whatever, anytime anybody asks for anything, the first thoughts you should have are, how can I do this consistent with the practice of least privilege and zero trust? Because if you use those to frame the implementation you will take, you will time and time again start out and complete in a much more secure fashion than if you just go, how do I get this implemented? How do I get this implemented? Because a lot of times when we do that, we almost subconsciously choose the path of least resistance. And in the current threat landscape and the current hybrid cloud type environments that we have and everything else, the path of least resistance often leads to devastating results. So we want to avoid that. So begin with that. And then the other tip that I was going to throw out is be careful of nomenclature. So for instance, in Azure, of course, there's a global tenant admin that is over the entire tenant. But then if you go look at a specific Azure type resource, let's talk about the Dynamics or the Power Platform, and you go in there, and there's these global admin roles in there. So make sure that when someone is asking for something, that you take a couple extra seconds and minutes to align it to what they're actually asking for. Because if you give somebody global tenant rights to your Azure tenant, and all they needed were those global admin rights to a business unit in the Power Platform, it's a pretty huge example that isn't likely to happen, but you get the idea, right? Just because they're named the same thing doesn't mean they apply to the same thing. So make sure that you're applying the rights that are needed for a specific thing and not something else.
Well, and I think this is one of the areas that cloud really shines, because in a lot of cases on-prem, we struggle to get identity management under control and under wraps, whereas in the cloud, it's kind of there for us, and we just have to enable and use those features. So that's one of the big things that I'm grateful for about kind of the cloud first everything mentality, is because I get access to some of these key and needed features kind of out of box. All right, just-in-time access. John, did you know that the most common attack surface for bad guys to get into systems today is still internet-facing, unsecured RDP connections? Can you believe that? So that means that you've taken your firewall, you've got a server on the inside, and you've opened up 3389 as the NAT rule, and la-di-da, you're able to get in and you're able to work remotely. Well, fantastic. You just solved a huge problem for COVID-19, and your users are back in business. They're able to access that, and you've also just given an infinite amount of time for bad guys to get into that infrastructure. Now, from an administrative perspective, it's a little bit different, because maybe we've actually got infrastructure and servers that we do need to manage, and maybe an RDSH host is a bad example. Maybe you just need to get in there and manage a SQL server or something like that you've got in the cloud. You're not going to use some type of point site, but you still need to gain access to it. So what Microsoft's answer to this is something called JIT, or just-in-time access. And so this is part of the Azure Defender SKU. And by the way, this is also a piece of advice that I have for you. Any of your infrastructure as a service roles that you have up in the cloud, you must enable Azure Defender. This is where you get that concept of a full guard, all of those additional security features. This is just not even a question for me for somebody that's had to help customers through ransomware. This is how Microsoft is going to enable advanced persistent threat protection on your VMs that are running up inside of your tenant. This can also span across to your on-prem infrastructure via Azure Arc connectors, which is Microsoft's basically bridge from on-prem to your cloud tenant. And so how this works is basically, instead of you creating what's called an Azure network security rule and opening up 3389, leaving it wide open, this kind of automates that entire process by saying, oh, well, first of all, you're going to need to request access. Second of all, what ports do you need open? Third, how long do we need to leave this open for? And fourth, what IPs is this going to be taking and coming from? And so is this going to be coming from a certain set of source IPs, a couple of them, or just one? And then I want to have an approval workflow inside of there as well. This is now built in for just-in-time access via Azure Defender. And 100% I recommend you turn on something like this. If you're using other cloud providers, they're going to have similar types of things. You want to look at just-in-time access as a very important topic of 2022. John, what do you think?
Absolutely. I've been a fan of just-in-time access for many years. On-prem, I'm a big fan of using JIT with GIA, so you have JIT GIA, right? And so now we're not only using our just enough administration technology, but we're throwing on top of the fact that we're going to use it just in time. Any of those things you do reduces your threat landscape and makes you smaller. And for anyone who has ever played the game of dodgeball, you will understand why it is so important to be the smallest target on your side when those balls are all being thrown at you and your teammates. So, when you make your organization smaller by keeping your administrative areas closed until you absolutely need them and then only opening them for as long as you need them, you by default improve your corporation's security. So just in time is the way to go.
Oh, John, we jumped ahead of ourselves a little bit with the cyber insurance piece behind there. So I'll just sum this one up and then we'll jump on to the next one. Remember, everyone, MFA for everyone is typically now a requirement as part of those cyber insurance policies. Security hardening is also part of those cyber insurance policy changes. Vulnerability assessments is now part of those cyber insurance policies, and you have to attest to that, as John mentioned earlier. John, I'm going to move on to the next one here because we have two very important ones left, and then we'll take a few questions here. All right. Training. Do you want to lead with this one here, John?
Absolutely. And, the way that we think of our team and our fellow IT pros is different in the current era, the cloud era and the current cybersecurity threat era and that sort of thing. So the way that we have to train ourselves and we have to train up our team has changed. And it's not that we haven't always had continuing education requirements and everything else. It's that, remember, when you talk about cloud particularly, you tend to be talking about, spinning up resources that have related components in different areas, whether it be resource groups and storage groups and networking and all these different things. So just being the Windows admin anymore doesn't fit. And when it comes to security, that couldn't be more true, right? We've already talked about a number of different things, everything from endpoint management to privileged identity management to all those different areas. So how do you get a handle on that? Well, one of the things that I'm a huge fan of, and in fact, I've made it a requirement for those working on my team, is that they go out and they pursue the Microsoft Security Operations Analyst training, because it offers such a great path to learn not only about all those technologies, but how they interconnect, how they play well together. And when it comes to security training, remember, this is part and parcel to your disaster recovery training. So whatever your DR strategy and guide of operations is, or operations guide, your business continuity plans, all that, it's going to be contingent upon your security. So the better trained your team is on cybersecurity, the better off you'll be. And for those of you out there that think, hey, that really isn't relevant to me because I'm not in IT security, I would challenge you and I would say that if you are working in IT today, whether you're working on the help desk or whether you're working in the corner office, you have a part to play in IT security. You are a part of your organization's cybersecurity strategy, and you are a critical part to whether that strategy will be successful or unsuccessful. So, welcome to the world of IT security for anybody that I just indoctrinated. We're glad to have you. Oh, and Dave, awesome. I will let you jump in and because you and I invented the cloud team concept, and I love it so much. But I'll let you go ahead and tell everyone about that.
Yeah, for sure. So typically when we're securing our infrastructure, we want to go through exercises. We want to have a bad guy team, a good guy team. And so what we would do is we would have the good guy teams take and try to secure things. We would have the bad guy teams try to get in, so the blue teams and red teams. But now we feel that John and I specifically feel that there should actually be a cloud team as well, because there's so many moving parts in the cloud that the cloud team also has to be brought into this exercise as well. So start looking at creating a cloud team to make sure that all of your security assets are secured in the cloud as well. All right, one more, and then we'll take some questions here, John. Team and threat hunting. Oh, yes, absolutely. So, my big thing with this one, I'll take one, and then I'll give you the other two. Using cloud as your friend. You only know what it is that you know, and having cloud-based AI technologies to help you sift through the mounds and mounds and mounds of information that are coming in on a daily basis from all of the different logs, aggregating those up into a central place is incredibly important, and this really becomes your IT outsourced security operations superstar, because the amount of data that it can process in a short period of time is so important. Then what you can do is you can actually use that information to, in turn, go threat hunt across your landscape, both in the cloud and on-prem, and to try to find vulnerabilities that are there. And so, John, we'll wrap up on this slide here. We've got a couple minutes, and then we'll take a question. I think we'll have to wrap up after that.
Hey, this is a great opportunity for me to remind everybody of that OODA loop concept that I talked about earlier. And hey, I'm not just a fan because the guy that invented it was also named John. Maybe there's something to that, but no, it's a good process. And this slide really speaks to that. Use AI. Use the tools that are coming out and available to you to increase the speed at which you are able to observe, orient, and decide, such that you get in front of your attacker and you're changing the set of events, the scenarios that they have to deal with to successfully breach you. Because the faster you analyze what's going on and react to it, the less likely they'll be to be successful. And a big part of that tool set has got an acronym of its own and a name of its own, so Security Incident and Event Management, SIEM. And that also is a common thread that you see among cybersecurity insurance carriers. They want you to be using some sort of SIEM solution. Well, the beauty is most of the major cloud providers have SIEM as part of their offering. So if you have a Microsoft tenant and you have, privileged identity management, you have E5 licensing, that kind of thing, you've got some great SIEM tools there. I'm not going to take any longer because I want to get to some of these great questions that our attendees have been throwing in at us.
Perfect. Thanks, everyone. And John Waters, do we have any questions coming in from our attendees?
You do. You have a few right here. I'll just kind of take it from the top. Here's the first one. How does Azure Blueprint compare in pricing?
Yeah, I'm actually not sure about that one. I think that question came in from Mohammed, and I would actually have to double check. I never posed myself as a licensing expert, John, but I don't actually know that there is a cost to it, not that I know of, because it's just configurations for an existing tenant. I would have to double check, but for sure, yeah, it's definitely something you want to look into. And great question, Mohammed. All right, next question, John.
Okay, so here's one from Dennis. He says, I believe Veteran Affairs is required by law to keep records of veterans for 100 years after they pass. Think of generalization impact of Agent Orange, I guess as an example. How would you suggest helping them with this legal requirement? Shocked that my grandfather's barn is completely missing. LOL.
Hey, Dave, I'll grab this one because you're exactly right, Dennis, and thank you for this question, that there are many organizations that have these long-term storage requirements. One of the things that we need to do as IT pros is not fight against these things, right? We're gonna say, okay, this is the requirement. But we're also not going to allow that requirement to be used kind of as a red herring to say all this stuff needs to be on our fastest enterprise class storage, because the reality is it doesn't, right? So let's talk about, think about that generational impact of Agent Orange. A lot of those records aren't pulled up on a day-to-day or probably even week-to-week or month-to-month basis. So there's no reason why a strategy where they are moved off into something like Azure Blob Storage or your Azure NetApp files, if you're using that, or that kind of thing, or any of the other providers. Obviously, I'm big into the Microsoft stack. But if you develop a solid strategy and implement a set of tools, they can be commercial, they can be your own scripts or whatever, whereby you are weekly or at the outside monthly, running these things, identifying dormant data and moving it to different tiers of storage. Not only will you help your organization comply with the long-term record requirement, but you will help increase their security standpoint, because now the amount of data that has to be recovered, say if we went to a DR event or something like that, it can be done a lot faster. You're able to also increase the likelihood of the records being there when they need them. Think 50 years ago when they had this requirement to keep these, they were talking about paper records. Well, how many different warehouses with paper records were the records destroyed by mold or fire or any form of any other thing? Well, when you tier them up in your cloud storage, guess what? That isn't going to happen because they're spread over data centers and different things. So you're not only going to make that requirement be met better for your organization, you're going to lower costs and improve security at the same time.
Thank you for being here. Thank you to our speakers, my fellow moderators, and of course, VMware for underwriting the summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization Cloud Review, here to moderate the second session of our summit called Architecting Security for the Cloud. Our speaker for this session is Brett Hargraves, Cloud Practice Lead at Iridium Consulting. Based in the UK, Brett has for over 25 years helped some of the world's biggest companies design and build cutting-edge solutions. With a career spanning infrastructure, development, consulting, and architecture, he has been involved in projects covering the entire solution stack, including hardware, virtualization, databases, storage, software development, and the cloud. He loves passing on his knowledge to others through books, including exam prep guides, blogging, and his online Udemy training courses, which have over 20,000 students and counting. Brett, it's great to have you here. Please take it away.
Hi, thank you, David. So as David said, my name is Brett Hargreaves. And as he also said, I've had a fairly varied career. A bit more. I started actually building desktop PCs before moving into networking. And it was around that time when virtualization was first becoming a thing. and I got involved in quite a number of large-scale VMware projects, and I could see at the time that things were, that was definitely the way the industry was going. An interesting thing is, about 10 years ago, I actually decided to flip my career from an infrastructure and became a software developer. And the idea is I wanted to move into application and solution architecture. I did this, and what I found interesting about the past 10 years as I switched my careers is that as I started developing and designing applications, and specifically for the cloud, I found myself started to come full circle. And I started to get more and more involved in infrastructure design again. And this time it was more in Azure and AWS. But the point is that throughout these different changes from infrastructure to software and back to infrastructure, the one thing that's always seemed quite constant is security. So security, of course, has always been one of the top considerations when designing any form of solution. And all the major cloud vendors, of course, publish quite detailed guidance in this area. However, today I just wanted to go into something that is often termed as security in depth. Now, traditionally, on-premise systems, when we design and build them, are secure by default. And this is certainly true from a networking perspective, because there's quite a natural barrier, which is the corporate network. So if you're designing a solution that needs external access, you actually have to architect that in and make configuration changes to make that happen by building something in the DMZ or opening firewalls. On the flip side, when we're using cloud, one of its greatest benefits is the fact that it's flexible and we can spin resources up really, really quickly. But it's this flexibility that also has its dangers, because the cloud is arguably built to be public-facing. And although, of course, there are technologies to securely extend your private network into the cloud and lock things down, by default, a lot of services are open and exposed to the internet. And so, because of this, when we do design and build applications, we have to be thinking about security in many different layers. We can't just assume it's always going to be there and configured for us. So what I want to do is go through a few examples as we go through that. But before I do, I just want to state that things do go wrong. And when they do, everyone tends to be left scrambling around to apply the latest fix or patch. And this was highlighted quite recently, actually, in the past month or so, with two vulnerabilities that were highlighted from Microsoft in the Azure space in quick succession. The first was an issue with Cosmos DB. Now, Cosmos DB, they introduced notebook integration, and this allowed people to access the keys that you would normally need to see the data in the Cosmos DB. And you could access those keys without having to authenticate. And this because this notebook integration just opened up a hole in the back end that could be exploited. This was quite quickly followed by yet another issue, this time on Linux VMs. And this was an OMI agent that automatically gets installed on all Linux VMs in Azure. And again, it was found that it contained an exploit that would allow full root access. Now, when these were released, some of the social media went nuts. People were being quite derogatory, really. And they were saying, obviously, Microsoft is rubbish and they make mistakes and it's not secure. And I thought this was, myself, really, really unfair. Because the big cloud providers such as Microsoft spend billions a year on security. They're not just developing security controls, but actively trying to hack their own systems and even offering bounties to other people who found vulnerabilities. And in fact, this is how the two latest vulnerabilities were found, because they offered this as part of the bounty program. People submitted these issues and they got paid for finding them. And I think what some people don't appreciate is that in recent years, many IT companies such as Microsoft have actually changed the way they think about solutions, how they're deployed, and certainly how they're secured. So thinking about that, I mean, if we go back 20 years or so, most products were built and deployed using the waterfall management approach. So in other words, we'd gather requirements, we'd define a solution, and then we'd build it and deploy it. But what often happened is that the customer would complain it's what they asked for, there'd be years of arguing, and the product maybe wasn't used or abandoned. So to counteract this, the first thing was to say, well, we'll start spending more time gathering requirements, more time on design, and then trying to tie the customer down into contracts. And we'd then go and build the system, deploy it, but again, invariably, it wouldn't work, there'd be problems with it, and again, we're back to where we were. So out of this, Agile was born. And at the heart of the Agile concept is quite simple, which is we're all human. Every technology is, especially all the software, it's all built by human, and it will eventually fail. Now, we can go to extreme lengths and great cost to prevent something from going wrong. But instead, we could embrace the fact that something will go wrong and then build in additional controls to adapt and remediate them. And then we can get on with the job of building the product. And this agile pattern is now being seen in lots of different areas. So, for example, once upon a time, hardware systems were built to increase the mean time between failures. So that's trying to increase the amount of time between something actually failing. But again, this was becoming increasingly expensive, and it still failed, and it just wasn't working. So part of using Agile, Microsoft Data Center started being built around a different concept called reducing the mean time to recovery. In other words, they were embracing the fact that hardware would fail. And rather than trying to prevent it, they tried to ensure that we could recover from it as quickly as possible. Now, you might be thinking why I'm talking about this. And it's because, essentially, this is what the concept of security in depth is all about. We could spend months, years, and millions of dollars trying to build a single control that was absolutely foolproof and unhackable. But all it takes would be a simple mistake, and often that would be by a human, and it's all for naught. Because all it takes is some code that was written years ago with some code that was written last week, and when the two come together, they offer an exploit that just couldn't have been predicted. So the security in depth principle is about accepting the fact that a single security control can fail. And rather than going to the nth degree to try and prevent it, let's try and build additional layers of controls that will still prevent us if that happens. So I'm going to give some examples of security in depth. There's actually quite a few, and offer covering many different aspects. And not only of solution design, but also we can look into how things are deployed. But first, let's take an example of a simple web application, and we're going to use Cosmo DB again, simply because that was something that was found with a vulnerability earlier. So the first thing, of course, we could implement multi-factor authentication. And this is, of course, now becoming the norm, as complex passwords are a pain, and users can still be caught out with phishing attacks and things. However, when we start building more modern applications using microservices and things where all these different systems need to communicate, MFA can't be used, because instead we need to use connection strings between two different systems. And this is one of the ways how the Cosmo DB flow was a problem, because it was using complex keys to connect to it. And once those complex keys were compromised, then we had a problem. So the first thing we can start doing now is securing the network layer. And this is a great way to prevent attacks, because if we take the two previous ones, for example, Cosmo DB and Linux, they were only available, they were unexploitable if you had network access to them. And both Azure, AWS, GCP, everyone, they all now provide software-defined networking tools, so we can really configure our communication between components and ensure that they remain internal. So in Azure, for example, we've got a number of ways we can lock down and secure our traffic. And as I say, there's lots of different options, but one of the important things is this in securing the traffic to ensure it's internal isn't done by default, certainly not in Azure. And so we have to make sure that we architect and implement it to keep our systems safe. So in the first example, how would we secure access to the database? So whether it's CosmoDB, SQL database, or even storage, these components have built-in firewalls where you can restrict the communications where the client is coming from. Now, we can restrict it down to web apps, APIs, or other services, and there is a traditional firewall in there where you can just open IPs. But of course, Azure, especially when we're thinking about things like web apps, they manage a lot of that networking, and so we don't necessarily know the IP, or it might be a big range that we don't necessarily want to open. So instead, we can use something called service endpoints. The service endpoints are a great way to connect web apps, Kubernetes clusters, functions, VMs, pretty much anything we want, to an internal VNet. And we can then configure the backend service, such as the CosmoDB, to only allow traffic from that internal VNet. And again, if we take the CosmoDB vulnerability that was found, if we just simply implement that one step, that would have meant even if someone could have grabbed the keys through the exploit, they still couldn't have accessed it. Using VNet integration actually also provides another ability, which is we can then start to implement network security groups and application security groups. And this enables us to also block the outgoing traffic from our application, which could be helpful because it could prevent attacks from insider threats. So if a developer has specifically written some code to try and send data out to an external service, and maybe even a virus if it got onto a VM running a web app, and again, then tried to reach out to a service. And then in this example, another great layer is to add a web application firewall, or a WAF. Now, in Azure, WAF is part of either an application gateway or a front door service. And it's an additional firewall appliance, but it works at layer 7. Now this means that rather than a traditional firewall that relies just on source and destination rules with IP addresses and ports, with the WAF, the packets themselves are inspected so that we can perform additional security checks. And so many WAFs implement or adhere to the OWASP standard, which is the Open Web Application Security Project. And these are a set of common standard attack vectors, such as SQL injection, cross-site scripting, bots, and so on. And so by sticking a WAF in front of our solution, we again add that extra layer that might otherwise have caught us out. And then when we have the app gateway in place, what we need to ensure we do is that we then block off any other access to the web app, because again, by default, a web app is externally available on its own URL. And then finally, with any solution, we should always be implementing logging and alerting. And again, in Azure, we can use simply Log Analytics, Security Center, Defender, or even a scene such as Azure Sentinel. And this just means that we can continually monitor attacks and send off any alerts to our security operations teams to follow up and further investigate. So another thing to consider from a security point of view is that, as well as thinking about the security of our individual components like we've just been doing, we can further secure solutions by thinking about the build and deployment mechanism. First of all, let's think about the build. Now, when we spoke about the CosmoDB vulnerability earlier, it's because we could get access to the keys. And another problem with using keys to access things like CosmoDB is that you have to give the keys to a developer who will store them, usually in a config file, potentially in code. And that causes us all sorts of other risks, either maliciously or otherwise. Because the developer might purposefully expose that key, they might accidentally expose the key. I've seen before where a developer has stored a key to a production system in a config file and then publish that to a public GitHub account. Now, there's multiple ways we can get around this issue, and one of them is simply to not give the keys to the developer at all and not use them in that way, so we don't store them in the config files. So what we can do instead is use a key vault. So a key vault is a protected mechanism that we can use to store sensitive information such as secrets, keys, and even certificates. So in this way, rather than instead of encoding that secret key in the connection string in a config file, we can instead store it in a key vault. And then the developer, when they're writing the code, rather than retrieving that key from the config file, it retrieves it instead from a connection to the key vault. Now, aside from negating the need to provide keys to developers, it also allows us to set up other things such as automatic rotation on keys. So, for example, we can set the key vault and the Cosmo DB to rotate the keys automatically every 90 days or so. And all this can be fully automated because it's all integrated into all the systems. Another option, so that we don't have to give developers keys, is to use something called managed identities. So rather than having the problem of a key or a password, we can instead configure certain services such as Cosmo DB, SQL, storage accounts, and so on, to grant access directly to our web application itself using RBAC roles. And in this scenario, the Microsoft platform, the Azure platform, automatically manages the keys in the back end, and you never ever see them. It's just managed by that underlying authentication mechanism. So the final bit I just wanted to go through was about the deployment side of things. Now, a lot of security issues can arise simply because an application or component hasn't been deployed or configured correctly, especially again in Agile, where we might often have to repeat deployments multiple times. So the fix here is to simply automate the deployments and make sure that everything we build, not just the software, but the infrastructure itself, is defined in code. So that includes virtual machines, web apps, databases, everything. We can define it in code. And this ensures that no matter how many times we deploy a solution, it's always deployed in exactly the same way, and there's less chance for configuration issues that might lead to a security event. Using infrastructure as code and automated pipelines also gives another opportunity, which is to hook into automated security mechanisms. So every time a developer commits some code to a GitHub repository or whatever, then that can trigger a scan on that code to look again for code vulnerabilities, keys that have been put in the code, and so on. And again, it's all automated. Any issues that are arise would either stop the deployment and could flag them. And then once we're happy that everything has gone to plan and everything is okay, then the deployment continues and our application gets deployed with increased security posture. And the point of all this is that security isn't just about the design of a particular component. We need to be thinking about all the components in the solution, as well as the deployment, so the build and the deployment process itself. Because if we can prevent common errors before anything's even deployed, then we are halfway there. So at this stage, I just wanted to run through an example of some of the areas that I've spoken about. So I'm just going to share my screen and run through a few demos. Okay, so if everybody can see my screen. Thank you. So what we have here, I've got a basic website, and it's very, very simple. It's just built using the Microsoft to do tutorial, and it's using an Azure web app with a Cosmo DB backend. I'll show you in the portal. I've actually created two Cosmo DBs. Now, this is because on one of them we're going to be implementing network security, and that can take some time when we update the firewalls. So this is the only reason why we've got two databases. But the main thing is, if we look at the first Cosmos DB, if we can see in the firewalls and virtual networks, it's completely open. So this means even from my own laptop, just connected to the internet, I could, in theory, go to this URI and try to access it. Now, if I do, it will throw up an authorized error. But the point is, I'm accessing it over the internet. So, if we go to the first option, which is this basic data fetch, this is just that's just gone to the database and retrieve some static keys. Now, if we look at the code, this is the process that's got that. And what we've done is, to connect to Cosmos DB, we need the account name, which is the URI, and we need that secret key we've been talking about. So in this example, I've simply got them from a config file, and we can see in this app settings file, all that information is just there. And the point is, it's there as open text in a config file. And as I said earlier, if a developer was to inadvertently leave that in and upload it and to a GitHub public repository, we were exposing our keys for our systems. So the first thing we can do is, if we go to the Cosmos DB protected one, what we can do is we can say, right, well, we're not going to allow access from all networks. We're only going to say selected networks. And if we try this first here, so if we try to access the data over this protected network, that's going to fail. Now, this option here is doing exactly the same thing. We're just getting the account and the key from our app settings file. I mean, it's a different key and URL, but it's still getting it from the app settings file. But now it's blocked because we've implemented that network security. And that tends to be the first level. So what we're going to do, we're going to open that up. So I'm going to add VNet that I'm going to allow access from, and I'm going to save that. Now, it's going to take a few minutes to do that. While that's just updating, just point out as well that, as I said, a lot of these things don't happen by default. So if we look at a web app, in order for this to work, we actually have to configure our web app to use networking. So in here, I've gone into this VNet integration, and I've specifically told or configured this web application to integrate with this VNet. And for this to work, that's an absolute must. We need to do that, and it is something that you need to specifically implement. Now, that really can take a while. So while we're waiting for it, I'll go on to the next bit, which is looking at key vaults. So again, we said, rather than getting our key from an X settings file, we could store it on a key vault. Again, we have here, I've built a key vault. And in our key vault, I've got a secret, or Cosmos DB connection key, and in there is my connection string, or my connection secret. We're going to go back here, and we're going to try and do the key vault fetch first, and it's failed. Now, that is because there's not much point storing things in the key vault if it's just automatically open. So with the key vault, there's a few things I've configured. The first is, again, I've actually restricted the VNets that can access this key vault. So again, I've restricted it to that web apps VNet. The next thing we need to do is we create access policies. So access policies are a little bit like RBAC and authentication. You can define what can access and read keys, and you can get really quite granular. So I'm going to go in and add a new access policy. Now I only want to read secrets. I'm going to select that, which just gives us a template for some basic permissions. But actually, I'm going to do away with all those. I'm just going to tell it, I just want to be able to get and list keys. The next thing we do is we tell it what needs to be able to access this. So in our case, this is our web application that we've built. So that appears as a principal, which I can just select. then I can add that in. And then I need to save it. I always get caught out by that. I always have the access policy but then forget to save. But there you go. So now if we go back in and do our key vault fetch, and now we're back and we can access the data. So again, if we look at the code, let's just go down here. The difference here is we've still got the account from the app settings file. But this time, rather than getting the secret there in our code, we're passing in our key vault URI, which again, we've still got from the app settings, but that's not too tricky. But now we create this key vault client, and we use this default Azure credential. And what that is telling the code to do is to authenticate and try to connect the key vault under the context of our web app that we're running under. So the next one that we'll do is managed identities. So if we go back to here, so our web apps have an identity. So this is built in, and this is object, and using this we can provide access. Again, this is the idea of the actual web app context that we authenticate under. Again, if we try and connect to it without doing anything, again we're getting a failure, and that's because we haven't told Cosmo DB to allow access to that web app identity. Now, RBAC controls on Cosmo DB are currently in preview, which means to assign that identity, and we can't do it in the portal. What we need to do is actually do it using the PowerShell. So I'm just going to add that in there. And 1 second, apologies. I've got the resource group wrong. And that's going to go away. And I say, unfortunately, this would normally be done in the portal. What we would normally do here is go to this access control tab, and we would add the roles in here. But as I say, at the moment, we've only got DB operator and backup operator and account reader roles, which don't give you access to data. And as I say, that's because that is currently in preview. Once that's done, we can then go in and we can say and connect using the managed identity. So again, if we hop on over to the code here, you can see the difference in the code here is that this time we're getting still getting the account name from the app settings. Again, that's fine, but now we're not grabbing any keys whatsoever, and instead we're creating our Cosmo DB client. And in this case, we're passing to it, again, this default Azure credential. So once again, it's saying, let's connect to the Cosmo DB under the context of the web app that we're running under, or specifically the managed identity that we're running under. So if we just have a look back, the networking is still updating, but sometimes it still works. Okay, and that time that has worked, so we'll just refresh that. So we can see, so we've gone back to the protected network. So again, this one is still using the static keys. But this time, we can only get to it because we've configured the Cosmo DB to only accept traffic from the VNet that's on. Now, obviously, all these different things can actually be mixed up, but the point is, again, a lot of these things don't happen by default. You have to go in and discreetly configure them in order for them to work and to secure our end-to-end communications. So before I finish off on the demo, one of the other items I was going to show is talking about the security in depth in multiple layers, and we spoke about a web application firewall. So as part of this demo, I've also created an application gateway. And the configuration's relatively quite simple. We've got the web application firewall enabled. Now, we can actually set it in detection and prevention mode. Now, detection will just log out if it sees any errors, but prevention will actually block them. Generally, what you would normally do is you would run it in detection mode for a period of time and then monitor the logs to see if there's anything that might cause you issues. And then you can either fix the issues in code or you can maybe even exclude them. And then once we're happy that everything should be working, we can switch it to prevention mode. And again, so if anybody tried a cause attack or a SQL injection attack, the WAF would actually prevent that from happening. We can also, this is using just a standard OWASP rule set, but we can actually get a bit more granular and tell it specifically which of the OWASP 3.1 rules to use. And actually there is also different rule sets that we can see here. But OWASP 3.0 tends to be the common one. Next, we configure our backend pools, which in this case is our website, and this is basically saying we're going to send all traffic that hits our app gateway to our backend app service, and this can integrate with IP addresses, virtual machine scale sets, and app services. It's quite flexible. Next, we set up listeners. So listeners is, rather than allowing all ports and blocking and allowing ports, instead we just allow ports. So by default, it won't listen. It's effectively blocking on all ports. And what we instead say is we can listen on which ports we want. Now on this one, I've actually set up what's called a redirect listener. So that means any traffic coming through to port 80 will get redirected to the secure rule, which is listening on 443. And then what we need is, in between the backend pool and the listener, we have rules. So we have our secure routing rule here, and this is where we say, okay, here's your listener, send it to that backend target. And actually in App Gateway, there's quite a lot of different configurations we can use. So for example, using the same gateway, you can have multiple backends, and you can direct traffic to different backends based on host headers or even routing rules. So a common option is you would have one URL, and anything that goes to the root would maybe get directed to a front-end website, maybe it's a React website. But if anything's got appended with a /API, so we're trying to get to an API backend, then we can tell it to route to a different backend based on that /API. So with that in place, if we go back to the overview, we can see we've got this public IP address here. Now I've actually set up a URL called mysupersecurewebsite.com, which is this here, and that directs to that URL. And so as you can see, we're getting the same website here that we got here, and that's just passing the traffic through from those front-end listeners through the rule sets, checking the packets to make sure there's no OAuth issues, and then pushing them through. However, we can still actually access our Azure website itself. So we can see here this URL. And that means someone could bypass the front door. So again, this is another one of those areas whereby it's not enough to assume these things will happen. We actually have to architect and implement the configurations to ensure our systems are secure. And so in this case, what we need to do, we need to go into the configuration of our app service. We go into the networking tab, which is where we set the VNet integration. But this time we set up access restrictions. Now by default, the rule is it allows all traffic through. So what we can do is add our own rule. And we can tell it to only accept traffic from a virtual network. and I'm selecting the subnet that our application gateway is on. Now, we could do it via IP address, but for simplicity, I'm just using the subnet. Now, with that in place, if I try to browse to the Azure websites.net URL, we now get access forbidden. Whereas if we go to our URL for the app gateway, everything still works fine. So that was just a few demos of some of the items that we spoke about. As I said, there's quite a lot of different things here. And I think what I've been trying to say throughout the past 40 minutes or so is that when we're thinking about security, it's not enough to think about single components. We really need to cover the entire stack. And that's, again, not just an individual component, but all the components in it and the build and deployment process. And so for this reason, security often starts with architecture. And one of the key principles is we've got to embrace the fact that individual security controls will probably fail at some point. And therefore, we have to start building security in depth in our applications, implement MFA, implement network integration and firewalls, WAFs, deployments, monitoring and alerting. So finally, I just wanted to say I do actually have a book out, as I mentioned earlier. It's the AZ304. The reason why I wanted to mention this is Microsoft have actually just recently updated the certification requirements for the Microsoft Certified Architect exam. And they've now done away with the 303 to a certain extent because that's covered a lot by administration. And so now the AZ304 has become the AZ305. However, it is actually very similar. And so even though the book is titled 304, it does actually cover all the requirements from the 305 exam. It is available on Amazon, but my publishers also allow me to give out 25% discounts using the code on screen if you are interested. So that's my demonstrations finished. Open to questions.
Okay, great job. And we do have some questions, and we'll get to those. But first, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. And let's move to the Q&A box and see what we have. First question reads, your examples are mostly platform as a service, PaaS. How can you add extra layers of security to VMs?
So that's a great question, and I think it was actually covered quite a lot in the prior lecture, which is there's a number of VM specific things, and one of them is Azure Defender, which allows you to implement things like just-in-time access. And that's a really great way, again, just to reiterate what was said earlier, to secure our VMs and is an absolute must. The other one is using Bastion services. So rather than building VMs using public IPs, we can build them all on internal VNets, which gives us that first layer of control. And then using the Azure Bastion service, we can front that across the VMs. And it means you effectively almost get a double authentication in because one, it's easy because you're going through a web browser, but secondly, you've got to go through those first few layers, and that Bastion is in effect a first layer of defense, and is a great way to lock down VMs from abuse.
Okay, great. Next question reads, are you suggesting you don't need to worry about patching vulnerabilities if you implement other security controls?
No, not at all. I think what we're saying is by implementing other security controls, by doing this security in depth, it means we won't get caught out. So if we take, again, the Cosmos DB and the Linux ones that happened earlier, they were reported to Microsoft, and luckily they were reported directly to Microsoft, but they didn't necessarily let everybody know about it straight away, because obviously they want to fix the services first, or at least come out with a patch. So there's potentially always a gap between a vulnerability being found and a fix being made available. And so by doing these additional security controls, it just means you're covered during that interim. And then, of course, as well, it might be a while before anybody finds out about them. So again, it's just good sense to have those there. But then once patch and things become available, of course, you still patch and bring it up to the latest security levels.
All right. I'd like to remind the audience we have plenty of time for questions, so please send them on in. Take advantage of this opportunity to contact an expert directly with your question. The next question in the Q&A box reads, you can create separate firewall devices in Azure and AWS, etc. Could you use them instead? WAF? Instead of WA?
Yeah, so firewall devices tend to work at a different level. A lot depends on your security posture, and also a lot depends on your enterprise architecture. So what I mean by that is, if you've got a very simple solution, like in the example I showed earlier, where we just have a web app and a Cosmos DB backend, and you're going to expose that to the internet, and it's always a public-facing application, then no, potentially you don't really need a firewall. The WAF provides you with many of the capabilities that you need and beyond. Where firewalls help is where you maybe have multiple solutions, and certainly when you start to integrate with on-premise systems, or if you need services that, again, are internal and not necessarily public-facing. Because then your firewall becomes your entry and egress point, and it means you've always got that central plane, that central place where you can configure network and firewall rules for your entire estate. But of course, that only works if your applications and your solutions are all built to make use of it. Because as we've seen, even if you have a firewall, you've still got to make sure that the network routing and things are connected in such a way to make use of that firewall. So the answer is yes, still use firewall devices where it makes sense, where you have a need, but they're not necessarily required. But when you do use them, you have to make sure your architecture and your solutions make use of them, because by default, that won't necessarily happen.
All right, great answer. Let's move right along to the next one. Question raised, not all services in Azure support VNet integration. How can you secure the networking then?
Yes, so some services don't, but that is true. A lot of Microsoft are adding more and more services that do support these kind of things. Some services don't, what I would call natively support. Again, you sometimes have to configure it, and sometimes there's a trade-off. So the one that always comes to mind is Azure Functions. But when you build Azure Functions, you can build them either as a consumption plan or as a service plan. Now, on a consumption plan, they're the full serverless option where you only pay as you use them. And they don't support VNet integration. And so in those cases, your only option would be to configure your storage firewalls to accept the traffic from the Azure Function service. And this is possible. Microsoft do publish all the rules for all their services. So, for example, function apps run in set defined ranges. And again, those defined ranges are also published on a region-by-region basis. So you can still lock your firewalls down to only allow function apps from the US, for example, US East or something like that. The other option as well is using private link IPs. Now, that sometimes depends on your overall connectivity scenario. So again, if you're coming from on-premises, then private link IPs are a great way to do that. But private link IPs are also used in some of the data platforms that Microsoft are developing. So I'm thinking things like Azure Data Factory and Azure Synapse. And with those, when you want to connect data pipelines between storage accounts and SQL or Cosmos DB, rather than doing it over those public access points, you can actually tell it to use the private link endpoints, although they're actually called managed private endpoints. And again, it effectively does the same thing. It ensures that all that traffic is kept internally, and you don't even need to then set the firewall rules. You can just, in the storage and the SQL, set the firewall to not allow any access, and it will use the private link IP instead. So there is options. Sometimes it's not always ideal, but there is usually options.
Okay, great. I think we have one more question in the Q&A box. And it says, your examples were Azure-based. Are things basically the same for other cloud vendors, such as AWS or GCP?
So there are differences. I'm not as much of an expert in GCP, but certainly in AWS, the way they build services tends to be a bit different. I'm hesitant to say secure by default, but certainly the majority of AWS services, when you build them, they are always built under the context of the VPC, the AWS equivalent of a VNet. That means even when you do their versions of functions, for example, so Lambda functions, they're always built on a VPC, which means you don't need to necessarily add these additional rules in like you do in Azure. The flip side, of course, is that you always got to be aware of the network ranges that you're building them in. So again, Azure Functions versus Lambda Functions is a great example. When you're building Azure Functions, if you're not bothered about the network security, then and you go for the consumption plan, then you don't need to worry about how many back-end services might get spun up to support the function, how much that serverless needs to grow by. Whereas in AWS you do, because the Lambda functions are still built in the confines of the VPC, you always have to make sure that the VPC is configured and built to be big enough to support the number of functions you might want to expand that to. And I've often found that tends to be certainly one of the biggest differences in my mind between AWS and Azure. Azure is they tend to try and abstract a lot of the underlying infrastructure away from you, but then they've started to add in these extra networking capabilities, whereas AWS has always been the opposite. They've always given you more access to that underlying stuff and more control over the networking.
Okay, we have a couple more minutes for questions, so send them on in quickly if you can. And in the meantime, Brett, I was wondering, as a cloud practice lead at a consulting firm, have you noticed any recent new trends in your work? In other words, how are things changing in cloud security, especially as it pertains to cloud security via architecture?
To be honest, I find it quite difficult. I think there's often a lot of confusion around security. And what I mean by that is architects sometimes don't fully understand what is required to architect things. And so a lot of the vendors are always bringing out new tools, and the example with the networking is a great one. Microsoft are now starting to build more and more services around the idea of using either VNet integration or private link IP. So they're starting to get on board with that now and starting to push that through. I think the other thing where there's a big change is it's certainly in the proactive monitoring of it. And what I mean by that is the introduction of scenes and how scenes get used, because I do still think there's a lot of confusion in how, not necessarily how to use scenes, but certainly how to configure them, because scenes are great. we send all these logs and all this information and all this, stuff to them that you can then use to analyze when you've been hacked, but it's no good when you've been hacked. So a SIEM really needs to be proactive and letting you know that, something's trying to happen and to hopefully proactively resolve that for you without your intervention. But for that to happen, you need to be aware of it. You need to build and configure those use cases. And I think one of the big changes is a lot of the SIEM providers now are trying to use AI to make that easier. And Azure Sentinel's a great one. There's a lot of stuff out of the box now where you can just say, I'll have that, I'll have that, I'll have that, and it configures the SIEM for you. And a lot more SIEMs are also started to go down that route.
Okay, well, it looks like that's all the questions we have time for. Thanks again, Brett, for a great presentation and answering those questions.
Thank you.